right, again, now we're on number 15, and the directions still say write an equation. In slope-intercept form, remember you use point slope to get to slope-intercept form. So it passes through our point, -4, 1, so I know that's my x1 and my y1, but it's perpendicular to this line. If I know the slope of this line is 5/2, the slope of my line is opposite, negative, reciprocal, 2/5. I don't care about this line at all anymore. The only thing I had to do was get the perpendicular slope. So I'm going to do the same thing I've been doing. Y minus y1 equals m times x minus x of 1. Remember, point slope gets you to slope intercept. So you have y minus 1 equals -2/5 times x minus -4 becomes +4. So go ahead and distribute your -2/5. So you get y minus 1 equals -2/5 x. And then on the side, let's go ahead, -2/5 times 4/1. You get -8/5. Go ahead, add 1 to both sides, and you get y equals -2/5 x. And then in some scratch work, -8/5 plus 1/1 is the same thing, times 5 times 5. -8/5 plus 5/5. -8 plus 5 is -3/5. So -3/5. So your final answer is y equals -2/5 x minus 3/5. Number 16, you had to graph f of x and g of x. F of x, my slope is 2/1. My y-intercept b is -2. So I'm going to go down to -2, up 1, 2 to the right 1, up 1, 2 to the right 1, down 1, 2 to the left 1, down 1, 2 to the left 1. And graph my line, and I have f of x. For g of x, I have a slope that equals 4/1, and my y-intercept is +1. So go +1, up 1, 2, 3, 4 to the right 1, up 1, 2, 3, 4 to the right 1, down 1, 2, 3, 4, left 1, down 1, 2, 3, 4, left 1. Connect, and I'm going to go ahead and label it g of x. Because my slopes changed number, I know that there was a rotation around 0, -2, because that is f of x, y-intercept. It went counterclockwise. Because f of x, if you started here, you had to go left, and that's counterclockwise, and got more steep. Because my y-intercept changed, I know that it went from -2 to 1, so it went up 1, 2, 3. So it translated up 3 units. Last but not least, this one here, we have to make a scatter plot. The following shows the number of calories burned by joggers over different time intervals. Time is my x. Calories burned is my y. So I'm going to go ahead and label time in minutes. And then calories burned. And I'm going to title my graph. I'll just name it calories burned jogging. Now if I look, my smallest time is 12 and my highest time is 22. So it goes by 10. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines. So I'm going to make a break. Zeros here. Start at 12. Go 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And that gets me the whole way up. I'm going to make a break again for my calories burned. My smallest calories burned is 93, and my highest calories burned is 161. So I'm going to go by a scale. I'm going to make a break, and I'm going to start at 100 and go, or start at 90 and go by 10. So 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190. And then let's plot. So we have 17, 132. It's going to be a little estimation. 17, 132 is about right here. 1293, so 1293. 14, 105. 14 goes up to 105. 22, 161, so 22 up to 161. 18, 139. 17, 136. 15, 120. Oh, that one's nice and even. 20, 142. There. And 16, 125. So 16, 125. Then we need to draw a nice trend line right in the middle. I'm going to draw a trend line that goes through the middle of my data. And I need an arrowhead on the right-hand side. Then part B says, using the slope formula, find the slope of the line of best fit. So I need to look at my line and find two perfect ordered pairs. There was a perfect ordered pair, 13, 100. And then I'm going to move up my line and see, oh, see if I find another perfect ordered pair. Oh, here's another really good one. So 17, 130. So I'm going to go ahead and use my slope formula. M equals y2 minus y1 over x2 minus x1. And yours might be a tiny bit different. So you have 130 minus 100 over 17 minus 13. So I got 30 over 4. So my slope equaled 30 over 4. So now it says write an equation in slope-intercept form. The same thing. I'm going to use 13, 100, and then my slope of 30 over 4. So I have y minus 100 equals my m, which is 30 over 4 times x minus 13. So I distribute and I get y minus 100 equals 30 over 4x. And if I do the multiplication of 30 over 4, so 30 over 4, so 30 times 13, I'm going to get 390 over 4. And this would actually simplify to 15 halves. So let's go ahead and simplify that everywhere to 15 halves. 15 over 2, 15 over 2, 15 over 2. And if you did it at 7.5, that's totally fine. So 7.5 times 13 equals negative 97.5. Add 100, add 100. So your final equation should be something close to y equals, and I'll just make it 7.5. I'll make my 15 over 2, 7.5, x minus 2.5. So then for part D, if you plan to go for a 30-minute job, that means that x equals 30. Use your equation to predict how many calories you would burn. So we're just going to plug 30 in for x. So you get y equals 7.5 times 30 minus 2.5. So 7.5 times 30 equals 225 minus 2.5 gives you 222.5, rounded to the nearest 100 calories. And yours might be a little bit off, but it should be somewhere very close to that.